temporal means time, right? Yes?
Yes.
Okay. So, temporal resolution pertains to the accuracy in time. So that means it's the accuracy of showing a structure that is moving. Okay, you guys remember that video that I showed you guys of that bird that looked like it was floating?
Yes.
Okay, so did that have poor temporal resolution or improved? Poor, right? Because we couldn't see the other wings flapping, right? Okay, if it was improved, you would be able to see the wings flapping up and down, right? Okay, so when in ultrasound do we need improved temporal resolution?
Color Doppler.
In motion.
Motion, what type of motion? Baby, huh? Not the blood, okay, so it's relative, yes, cardiac, okay, so for the Doppler strip, it is relative, but not so much. What we're talking about is cardiac, okay, so what does the heart do?
Pumps.
It pumps,
Contract.
expands and contracts, now what's happening inside the heart?
Beating.
Huh?
It's beating.
No, inside the heart is beating, yes, but what's happening inside the heart?
Circulating.
The blood is going through valves, right? The valves are these little flaps, okay? So, do you think those flaps move slow or fast?
Fast.
Fast. So what happens if we misidentify a flap that is stuck?
Maybe he has like
Regurgitation, okay? So the blood should be going in a forward direction, but it goes backward, okay? Is cardiac regurgitation good? No. Okay? And they're gonna go in there, try to do surgery to fix that flap, when all along our temporal resolution is up, okay? So temporal resolution is relative to the accuracy of movement in imaging, okay? So it describes the ability to precisely position moving structures from instant to instant. Temporal resolution is determined by the frame rate. Displaying a high number of images per second, which means high frame rate, improves temporal resolution. Okay, so what type of a relationship does temporal resolution and frame rate have?
the same.
They're directly related, yes. Okay, so the higher the frame rate, the higher the temporal resolution. Does everybody understand that? Okay, temporal resolution is related to frame rate, which is measured in hertz. And what does hertz mean?
Frequency. Per second.
Per second, yes, per second. Okay, so how many frames per second? So which one has a higher resolution, 10 hertz or 5 hertz? 10 hertz, right? Because the higher the frame rate, the higher the temporal resolution. Everybody understand that? Yes? Lady?
Yes.
Yes? Okay, now frame rate. Do you remember frame rate? We did this in the first physics. Remember?
The number of images per second.
Okay, frame rate is the ability of the ultrasound system to create numerous frames each second. Okay, so if I make one frame in 1 second, what's my frame rate? What's my frequency?
1 second.
1 megahertz.
1 hertz.
Hertz.
Hertz. Remember, I said seconds.
Okay.
Okay, now if it can make 10 frames in a second, what's my frequency? 10 hertz. Okay, that's exactly what it is. Okay, so frame rate is determined by 2 factors: the speed of sound in the medium and imaging depth. Okay, first of all, why is the speed of sound in the medium, why does it influence the frame rate?
We're gonna be able to pick up the returning.
Okay, so I think what you're trying to say is that if your speed of sound is lower, it takes longer for the echo to return. Okay, which is exactly right, because how does a machine know when to send out a pulse?
After it receives the.
After it receives it, right?
Yeah.
Okay, so the lower the medium, or sorry, the lower the speed of sound in medium, the lower the frame rate, okay? So speed of sound in the medium and frame rate have what type of relationship? They're directly related, okay? So the faster the speed of sound in the medium, the faster the frequency, which means the faster the frame rate. Okay, now what about imaging depth? How does that influence the frame rate? Andy, I can see a little squirrel in the cage running.
It's the same thing, the deeper it has to go, the more images it's gonna see, so it's inversely related.
Okay, so you got the university right, but you got the reason why wrong.
Okay.
Okay, so the deeper it goes, the longer it takes for, yes, the longer the listening time.
Okay.
So the longer the listening time, the longer it has to wait to send the next pulse. Okay, so imaging depth and frame rate are inversely related. Okay, so the deeper the distance, the lower the frame rate. Okay, does everybody understand that relationship? Okay, because it's about to get mixed up now. Okay, because now we have T-frame. Okay, so we have frame rate is the amount of frames per second, okay? And our T-frame is the time it takes to make one frame.
Okay.
Does that make sense to everybody?
Yes.
T-frame is the whole image.
No, no, no. Okay, so the frame rate is like the video, right? Okay, so so have you guys seen like on the iPhone, when you get a video and you get edited, it has a bunch of different slices?
Yeah.
Okay, so each of those individual things is a frame. Okay, if you put it together, it makes a video. Okay, now just imagine those frames being stretched out or shortened. That's a T-frame. That's the time it makes to make one frame. Okay, so frame rate and the time for one frame are inversely related and are reciprocals. Okay, or T-frame times frame rate equals to 1. Okay, if our frame rate is 1 hertz, how long did it take to make one frame?
No, 10.
Okay, if our frame rate is 1 hertz, how many seconds did it take to make
Okay,
one
1
frame?
second.
1 second.
1 second. Okay, 1 second.
Bless you.
Okay, does everybody understand why? 1/1 times 1/1 is 1. Okay, now, if our frame rate is 10 hertz, what's our T frame? 4?
Times.
0.01.
Huh?
0.01.
0.01. Okay, so it took 1/10 of a second to make one frame.
Okay.
Does that make sense?
Yeah.
Are you sure?
Wouldn't it be 0.1 instead of 0.01?
Oh yeah, 0.1, yes, 0.1, yes, I'm sorry.
Sorry, I was thinking yesterday, the 1
Yeah.
over 100.
Yeah, we just moved the decimal over 1. Okay, so just divide it by 10.
I was testing you.
Yeah, I failed, I'm sorry. So, let's try to do a drawing of this. I just heard a really disturbing story a couple of weeks ago about a coworker.
Here?
Yeah,
Or
involved,
BCT?
involved butt pads.
What?
Butt pads. Yeah, an employee was in the stall and then another employee went into the stall to do their work and like the pads fell on the floor. But I don't know if that's true or not. And I didn't even know that they have foot pads, it's crazy.
A male day?
What?
A male?
No.
Oh.
Okay, so we have our frame rate, right? Is equal to 10 hertz.
Mhm.
Okay, so what that means, that in 1 second, there was 10 events.
Yeah.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, there was those 10 events, okay? Or 1 over 10, right? And if we do the math, it would be 0.01 seconds. Okay, so each of these frames took 1/10 of a second to create. So if we do
One second.
if we add all of these together, what do we get?
1 second.
1 second. Okay, so it took 0.1 of a second for each of these frames to be made. And that's what gives us our frame rate of 10 hertz. Okay, does that make sense? Sabrina? You sure? I like the way you're looking
So 20 hertz.
at it. 20 hertz, it's the same thing with double.
So
Okay.
sorry,
Go ahead.
so would the frame time be 0.1 second?
Yes.
Okay.
So our T frame is 0.1 second, or 1/10. Okay? So frame rate, T frame, inversely and reciprocal. So if you have the frame rate, it'll tell you if you have the T frame, you can figure out the frame rate, right? So it'll tell you that the T frame is 0.2. What's the frame rate?
20, yeah, no.
Is it?
It'll be 5 hertz.
I know, what do you guys think? How'd you get 5? Huh? In your head?
Should be.
It's 2. Or
2 hertz.
20 hertz? 2 seconds.
2 hertz?
Oh, that hurts.
Maybe 20?
Yes. Wait,
I'll be, cause 20 will be 0.05.
oh, wait, I don't know.
Making me question myself.
Should be 5.
Hold.
It's just, I don't know. 1 over, you said 2.0 or 0.2?
Okay,
think it is 2.0.
so if our T frame is 0.2 seconds. What's that frame rate? What's the reciprocal of 0.2? Or what's 0.2? What's 0.2 in fraction?
Yeah, how would you reverse it? Like,
I can do reverse, I don't know.
Well, what's the fraction of 0.2?
wait, okay, I need my calculator. You divide that?
Okay, so
Divided by 10?
what is this number?
20.
2.
20 point.
2.
Oh, it would be
20%.
And it's in the
Five.
tenths. It's in the tenths,
Yes,
right?
Yes. So we choose
1
every
0?
10.
so 5 hertz.
Wait, why would you lost me?
So then you add
Don't
the
do that.
2.0.
Why would you do that?
Okay, so then the reciprocal would be 10 over
It's just so
2
simple.
or
5.
5.
Wait, how'd you get 2 over 10? Sorry, like how would I?
Okay, so the fraction,
Cause
the,
it's oh,
point
it's in
two-
the 10 place, okay.
yes. 0.2 is equal to 2/10.
So what about the 5?
5 hertz.
That one I want.
Is it 2
That made me confused.
0.25?
Okay,
Can we do another one?
no. Let's stay with this one, okay? Let me explain this one. Okay, so our T frame. Okay, I'm gonna give you the T frame, right? The T frame is equal to 0.2 seconds. Okay, and we know that the T frame is a reciprocal of the frame rate, right? Okay, well, how do we get a reciprocal? We can't do a reciprocal of 0.2, right?
No.
So we need to turn it into a fraction.
Yes.
Okay, so what is 0.2 in a fraction?
2
Okay,
over.
so we have our whole number here, our numerator, which is 2, and it's in the tenths
Oh.
position. Okay, 2/10. Now we can do our reciprocal, right?
Yeah.
Our reciprocal is 10 over that, 10 over 2, okay?
Okay, that makes sense.
Which is 5. Which is 5 hertz. Okay, now, what's the reciprocal of 5?
1 over 5.
1 over 5. Which is 2 over 10 simplified.
Okay.
Okay, so you can reduce it here, or you can just divide it. It's up to you. Delco?
I understand it, but I had a way to do it, not like that.
Can you
I
share
got
with
the
us?
same answer.
Can you share with us?
Come on, gold.
It's
The clapping.
it's just okay. So if the T frame is 0.2,
Uh-huh.
you just put 1 over 0.2, and it's gonna equal to 5.
Is it gonna work
Like
like
how
that?
we.
Yeah, because if you have the because it's gonna be equal to 1 regardless, because they're reciprocal.
So let's try for point 3. This is the T frame for point 3.
Point 3 would be,
Oh, now that is confusing. Can we just not do it this way and keep it in the
would be,
What do you get?
What? I just did 1 over 0.3, right?
Yeah, and what does that give you?
3.33.
Huh?
3.33.
so 3.33.
Why did you
Hertz.
make it hard?
Because you need to know how to do this. You need to know how to turn a decimal into a fraction and know how to do a reciprocal of a fraction.
Jesus Christ.
My name is Pascual, okay, not Jesus Christ.
So would that be,
Okay, so in short,
no more questions?
if you know the T frame, you know the frame rate. If you know the frame rate, you know the T frame, because there are reciprocal and
So if you, when you do the dividing, like, you just ignore the number
Oh,
after
where
your
is it
tens
gonna-
place, like you did with 0.25?
Oh, it's
No, that's a second.
Oh,
0.2 S for seconds.
oh, it's a second, it looks like a 5.
No, that's an S. Sorry. Okay. So T frame times frame rate equals 1, which means that they're reciprocals, right? Okay, when an ultrasound creates an image in 1/10 of a second, the frame rate is 10 frames divided by second, or 10 hertz. Okay? So this is our T frame, which is 1/10. So what's our frame rate? The reciprocal of 1/10 is
10 over 1.
10 over 1, which means our frequency is 10 hertz. Okay, does that make sense?
Yes.
Yes.
Okay, so two sonographer control settings of an ultrasound system determine the frame rate, the imaging depth, and the number of pulses in each picture. Okay, so how does the imaging depth influence the frame rate, or T frame?
Very interesting.
The seconds and that has to be like shorter time is like a shallower image, and then like a longer time is a deeper image.
Okay, so yeah, all right, so when it comes to T frame, longer depth, or sorry, deeper depth or longer distance means a longer time to make that one frame.
Okay, longer to
So they're, yes, so they're directly related.
Wait, what are the two that are directly related?
T frame and depth. Okay, so if we're traveling 5 centimeters, it's gonna take longer to make that one frame, as opposed to traveling 1 centimeter, it takes a shorter time to make that one frame, right? Okay, so what relationship does T frame and frame rate have?
Directly.
They're inversely related, right? So frame rate is inversely related to depth, right?
Yes.
Okay, because frame rate and T frame have an inverse relationship. So If depth is inversely related to frame rate, it's gonna be directly related to T-frame. Okay, now, number of pulses in each picture. Okay, so how do you think the pulses influence the image? No, the number of pulses, not how long they are.
Well, the more pulses, the more better
Okay.
resolution.
The longer it's gonna take. the-
Okay, but let me hear what you said, real quick, what'd you say?
The more, the number of pulses, the better the resolution.
Okay, that's correct. Paul?
I was gonna say this.
Okay, Ayeli?
I was gonna say the number of pulses, it takes longer. longer
Exactly.
deeper.
Exactly. Okay, so if we have more pulses per scan line, it's true, our resolution is better, our pictures look better, but at the cost of the frame rate. The frame rate. The frame rate, okay, at the cost of the frame rate. So if our frame rate goes down, our temporal resolution goes down. Okay, so just imagine that you're trying to sort marbles, right? Okay, I give you guys a huge bowl of red marbles, and I tell you, sort these marbles for me. You're gonna be able to sort them out easily, right? Because there's only one color, right? Okay, now, if I gave you that same bowl with 3 colors, let's say red, blue, and yellow, is it gonna take you longer to sort those 3 colors out?
Yeah.
Yes, right? Okay, so it's the same thing with the pulses, okay? If you have 1 pulse in a scan line, it's easy to interpret that information, right? But if you have 3 pulses, you gotta take the information from those 3 pulses and interpret those, so it takes longer. But we're given more information, which makes our image look better. Okay, so when does that benefit us? Having more pulses per scan line?
One scanning
Deeper structure.
Actual res.
Deeper structures or structures that are stationary, right? Like what?
Gallbladder.
The baby.
Gallbladder, the fetus, the liver, the kidneys, the thyroid, the testicles, breast, all those structures are stationary, they don't move, right?
Yeah.
So we could sacrifice our frame rate to make our image look nicer, Right? Okay. But
On the heart, yeah.
on the heart, we can have that many scan lines, right? Because we need to make sure that our frame rate is as high as possible, so we can accurately see those flaps moving up and down, right? Okay, so our image isn't as great, but our frame rate is awesome. Okay, so it's always a give and take. We can't always have everything that we want. Okay, sometimes we have to give something to get something.
You ever use like 2
Compromise.
I've never used 2 probes at once, because we would have to use 2 machines.
That'd be cool.
That would be pretty cool.
So on that one, the number of pulses in each picture is inversely related to frame rate.
To frame rate, yes. More pulses, lower frame rate. Less pulses, better frame rate. Okay, so they're inversely related. Now, since we know that the frame rate and pulses are inversely related, what does that tell us for T-frame? They're directly related, right? Okay, so the more pulses, the longer the T-frame, okay, goes up. The less pulses, the shorter the T-frame, okay, they're directly related. Okay, so imaging depth and frame rate are inversely related, right? Okay, so the deeper the structure, the poorer the frame rate.
Yes.
The more shallow the structure, the better the frame rate, the improved frame rate. Okay, they're inversely related. Okay, so T-frame, okay, the time it makes to make 1 frame. T-frame is equal to the number of pulses times the PRP. Okay, so if we increase the pulses, what happens to our T-frame?
It goes up.
It goes up, okay, the time for the T-frame goes up, which means what for our frame rate?
Goes down.
It goes down, because T-frame and frame rate are inversely related. do the math ready? Or were you texting somebody while I was?
I was in
Okay,
there.
so what is a frame rate of 100 pulses and a PRP of 1,000?
.1
Point one what?
fraction. No.
Trigger.
Sure.
Point 0.001
What's the unit?
frames per second.
You do it per second?
Okay,
It has to be seconds or
Alright.
something.
So this equation that you use is the equation for what?
T frame.
T-frame, okay? So if our T-frame is 0.1 seconds, what's our frame rate?
Oh, 10.
1 hertz.
1 hertz, 1 hertz, right?
Yeah.
Okay, so the reciprocal of 1 over 1
The reciprocal 1
is 1, right? 1
Yeah.
hertz, okay? Or, sorry, 1/10, no, I'm wrong, sorry. Okay, so it's 0.1, what's a fraction of 0.1?
110.
1/10, what's the reciprocal of
10 over 1.
over 1, so what's our frequency? 10, 10 hertz, 10 hertz, you're right, 10 hertz.
Okay.
Okay, because we know that 0.1 in fraction form is 1 over 10, or 1 over 10, the reciprocal of 1 over 10 is 10, which is our frequency. Okay, so what's the frame rate if we have the distance?
No.
Can you explain it better?
Oh, man, we're supposed to get through the whole thing today. Okay. So this is a lot easier than you think.
2 hertz.
Nope. Almost. Okay. So this is a reasoning problem, okay? So T-frame is equal to number of pulses times PRP, right? Okay, so 100 pulses. Not the wrong thing. So I give you 100 pulses times 1 over 1,000, right? Which is also what?
0.001.
Yeah.
0.001, right?
Yeah.
Okay. So if we take off the 2 zeros, we're left with 0.1, right?
Yes.
Okay. So this is 0.1 seconds. This is our T-frame, right?
Yes.
Okay. In fraction form, what is this?
1 over 10.
1 over 10, right?
Yes.
So we know that the reciprocal of 1 over 10 is what? Okay, so our frame rate equals to 10 hertz, right? Okay, now, what relationship do frame rate and depth have? They're inversely related, right? Okay, so I said if we have the distance, okay, so that means the distance, okay, so frame rate and distance are inversely related, right? Okay, so if I have the distance, what do I do to the frame rate?
No.
And they're inversely related.
Increase it.
Increase it by 2.
You multiply it by 2. Because we did the inverse to it, okay? So if we, 20 hertz. So if we have the distance, we double our frequency, which is 20 hertz.
I got that, but I did it differently. I did like the, I just, okay. Because I didn't know it's right.
Just do like this.
Okay.
Wait, so from 10 hertz, what were we looking for again?
Okay,
20?
so we found the frequency, right? Or sorry, not the frequency, the frame rate.
Yes.
Which is what I was asking you,
Uh-huh.
right? We found the frame rate because we found the T frame. These are inversely related and they're reciprocals. Okay, now with the same question, I asked you, what would happen if we halved the distance? Okay, I didn't give you the distance,
Okay.
but we know through reasoning that if we divide the distance, we do the opposite to the frame rate, which is multiply times 2. So that's how we get 20 hertz. 10 hertz times 2 is 20.
Okay.
Got it.
Sabrina, is that a little bit clearer?
Yeah.
Okay, if you guys have questions, let me know.
We got the question,